Today, we are diving into a really fascinating and honestly kind of mind-bending idea in AI. It comes from a paper called Better Together, and it explores a question that most people just weren't asking. The answer, though, could seriously change how we build intelligent systems. So let's get into it. All right, here's how we're going to break this down. We'll start with the wild question that sparked all of this, then we'll look at a huge problem that holds AI back, and the clever solution they came up with called UML. After that, we'll dig into the core philosophy that makes it work, check out the proof, and then wrap up with why this is such a huge deal. So, this whole thing kicks off with one simple but really counterintuitive question. Yeah, you heard that right. Let that sink in for a second. Could an AI literally get better at seeing things just by listening to a bunch of totally unrelated sounds? I know, it sounds weird, but this overlooked yet potentially powerful question is the absolute key to this entire breakthrough. Now, to really get why that question is so important, we have to talk about a major roadblock in AI. It's often called the paired data problem. So here's the deal. Usually, for an AI to learn that the word dog is connected to a picture of a dog, you have to feed it tons and tons of examples where that exact picture is matched with that exact caption. This is how models learn to connect different senses or modalities, like vision and sound. But you can probably guess, this creates a massive bottleneck. And this slide just lays it out perfectly. On the left, you've got that pristine, hand-matched paired data. It's great, but it is super expensive and takes forever to create. Now look at the right. That's unpaired data. The world is absolutely swimming in this stuff. Just endless images, oceans of text, countless audio files, none of it connected. So the big question is, what if you could teach an AI with that messy pile of data? And that is exactly where this brilliant new solution comes into play. It's called the Unpaired Multimodal Learner, or, you guessed it, UML. So what is UML? It's basically a whole new philosophy for training AI. Instead of needing those perfect pairs, you use one single super flexible model. And this model can process different kinds of data, say an image, then some audio, one after the other. And the whole time it's sharing what it learns across both tasks. It's built from the ground up to make sense of that huge, messy pool of unpaired data we were just talking about. The way it works is actually pretty elegant. Okay, so first the model takes a look at an image. Then it processes a totally separate, completely unrelated piece of audio. But step 3, this is the magic. It keeps alternating between the two, and crucially, it shares its internal knowledge. Think of it like its brain power between both jobs. As it does this over and over, it builds a way richer, more powerful understanding of the world than it ever could by just sticking to images alone. Okay, I know what you're probably thinking right now. How is that even possible? How can learning from random audio help an AI understand images if they have nothing to do with each other? Well, the answer gets into a really beautiful idea about how the world works. This is the absolute core of it, the aha moment. The idea is that everything we see, hear, or touch, they're all just different projections, like shadows on a wall, of the same single reality. So even if a picture and a sound aren't directly linked, they both contain these faint, hidden clues about the structure of the same world. Let me give you a quick analogy to make this super clear. Imagine an object's shadow and then the sound it makes when you tap it, right? They are two completely different kinds of information. One is visual, one is audio. They are not paired in any neat way, but both give you clues about the same object. The shadow tells you about its shape, the sound tells you about its density, what it's made of. UML basically teaches an AI to find those hidden connections all by itself. All right, so it's a fantastic idea in theory. It sounds great, but the real question is, does it actually work in practice? Well, the researchers brought the receipts. And they proved it in 2 solid ways. First, with math, a theoretical proof, and second, with real-world results, empirical proof. The theoretical part is really powerful. The math shows that when you add this extra unpaired data, like throwing random audio into the mix for an image model, the final result is, and I'm quoting here, strictly more informative. That's a technical way of saying it's not just a little better, it is provably, fundamentally smarter. And of course, the real-world experiments backed it all up. When they put it to the test, using UML to train with unpaired data, text, audio, you name it, it consistently made the model better at its actual job. It wasn't a fluke. It just works. And I mean, look at this. The numbers don't lie. On the left, you've got your standard model, trained on just one thing. It does okay. But on the right, the UML model, that got to learn from all that extra, messy data, wow, the jump in performance is huge. It's not even a close competition. So let's zoom out. What does this all mean for the future of AI? This is really where it all comes together and gets exciting. The big takeaway here is nothing short of revolutionary. It means we don't always need these perfect, expensive, hand-curated data sets anymore. We can now tap into the chaotic, messy, but absolutely massive amounts of data that are just floating around out there to build AI models that are stronger and just better. And this is a total game changer. For one, AI training just got way more efficient. It also unlocks these giant data sets that were pretty much useless for this kind of work before. It even makes models designed for one specific task stronger. And maybe best of all, it cuts down on the insane cost of pairing data. Just imagine an AI that gets better at spotting tumors and X-rays because it's also been learning from unrelated doctors' notes. That's the kind of potential we're talking about.
This really shifts the entire paradigm, right? We're moving away from AI that needs perfect, clean data to an AI that can find wisdom in the noise. It's about searching for that underlying structure of reality. So it leaves us with this one final really cool question. If an AI can learn to see better by listening to random sounds, what other hidden connections, what other echoes of our shared world is it going to find for us next?